So yesterday we kind of started an introduction into quadrilaterals, and if you remember, a quadrilateral is just a shape that has four sides. It's the most generic form of a four-sided figure is just a shape with four sides. So it can literally look just like anything. Here's a shape with four sides. I don't really know anything about it. It just has four sides. Okay? So that's a quadrilateral. The second term that I know is going to be important is to talk about parallel. And we talked about parallel lines yesterday. Parallel just means that I have two lines that never cross. They're never going to intersect. And if you remember, when we talked about parallel lines yesterday, I used a certain type of notation for this. If I want to indicate that the top two lines here are parallel, I do these little arrows, and that shows that those two lines are parallel to one another. Okay, so they're lines that are never going to cross. Okay, the next one is congruent. So congruent just means same. They're the same. So I can talk about congruent. Let's do this. It's the same. I can talk about two different things being the same. I could have the same side, congruent sides, and I can have congruent angles. Okay. When we're specifically talking about quadrilaterals, we're probably mostly going to be talking about sides. There's a couple times when we'll care about angles, but for the most part we're going to be looking at congruent sides. And if you think about, so I have a rectangle here, right? I use these tick marks to say that they're congruent, these little lines. So I would have that these top two ones are congruent, and then the side two lengths are also congruent. That means same. Okay, the next one that we'll talk about is a trapezoid. So we talked about the trapezoid yesterday. I made a comment that there was one type of definition that we're going to use for this, and so we're talking about a trapezoid. That means that we have a shape with exactly one pair of parallel lines. So this is the kind of figure that we'll see most of the time when we're talking about a trapezoid, is it's going to kind of look like this. So then I would have this line. Let's use a different color to have it stand out a little bit. I would have this is parallel to that, right? I have one pair of parallel lines. That is a trapezoid. A kite, maybe this is a little more helpful if I can show you the shape that I'm talking about when I'm talking about a kite. So kites look like this. Okay, and you can kind of think of when you fly a kite, that's kind of the typical form a kite is. And here's the actual definition of a kite. So I'm going to have two pairs of congruent, so congruent means same, and adjacent, remember, means next to, two pairs of congruent adjacent sides where the opposite sides are not congruent. And I'll show you what that means. I'll let you copy that down first. So 2 pairs of congruent adjacent sides where opposite sides are not congruent. Here's what this looks like. So that means that these 2 lines are going to be congruent, and these 2 lines are going to be congruent. So I have 2 pairs of congruent adjacent sides. They're connected, where the opposite sides are not congruent. So this side, I didn't want that to be green. This side and this side are not the same. Opposite sides are not congruent. That's what that is talking about. Okay, that's a kite. We also have a parallelogram. Parallelogram is where opposite sides are congruent and parallel. So sometimes you'll see these as like slanted, kind of like this. So here's my parallelogram. What this is telling me is that this is parallel to that. Let's do 2. This is parallel to this, and all of the sides are the opposite sides are also congruent. That is a parallelogram. Opposite sides are congruent and parallel. I don't know anything about the angles with this. I'm just looking at the sides. They're going to be congruent and parallel. Okay, a square. This may feel like, duh, Mrs. Olson, I know what a square is, but it's important to make these distinctions, right? So that, because they're not all, we have a specific way that we talk about squares. So a square is when I have 4 congruent sides and 4 right angles. A right angle, remember, is 90 degrees, so I have 4 congruent sides and 4 right angles. So you know what a square looks like. That looks more like a rectangle, but that's better. So I have 4 congruent sides. All of these sides are the same. And then I have 4 right angles. This is a square. 4 congruent sides, 4 right angles. A rectangle, then, is when I have 2 pairs of congruent sides and 4 right angles. So in this case, we have the rectangle. This side is congruent to this side. This side is congruent to that side. And I have 4 right angles. The last one is a rhombus. So a rhombus is a parallelogram with 4 congruent sides. And remember, a parallelogram is when opposite sides are congruent and parallel. So if a rhombus, most of the time we see is slanted, looks like this. I have all of these sides are congruent, and then my opposite sides are also parallel. So this is parallel to that. This is parallel to this. So a rhombus is a parallelogram with 4 congruent sides. And this is where I talked yesterday about how we need to pay attention to the most specific form of the quadrilateral. So, for example, this rhombus, right, is a parallelogram. So it's a parallelogram with 4 congruent sides. So it is true that a rhombus is a parallelogram, but if I have a parallelogram where all 4 of my sides are congruent, the most specific way to talk about that is it is a rhombus. So let's look at just some examples. So letter A here, it wants me to classify the quadrilateral. So I'm going to look for important pieces. So one of the important pieces that I see is that all 4 of these sides are congruent. Second thing I'm noticing is that there are 4 right angles. So if I want a shape that has 4 right angles and all the sides are congruent, that means that I need a square. Because I have 4 congruent sides and I have 4 right angles. And here's where this may feel kind of tricky. Like you could look at this and be like, well, it could also be a rectangle, right? My opposite sides are congruent. I have 4 right angles. Could be a rectangle. It could also be a parallelogram because those are all going to be parallel to each other. It's a quadrilateral, obviously, but the most specific thing that we can say about this shape is that it is a square. That's the most specific we can be. So if I look at part B, here's what I'm noticing, is I'm noticing I have these congruent sides here. I have 2 more congruent sides over here, and they're next to each other. So I have 2 pairs of congruent, adjacent sides. And I know that a shape with 2 pairs of congruent adjacent sides is a kite. Okay, so here's what I want you to do on your own. These next 3, classify each of the quadrilaterals, and I want you to, as I did up here, not only tell me what the name of the quadrilateral is, but I also want you to explain why. So I knew that this was a square because it has 4 congruent sides and 4 right angles. So look at these shapes, tell me which one it is, and then tell me how you know, okay? So go ahead and pause here, do the next 3 on your own, and then you can come check your answers with me when you're done. Okay, so here's what you should have gotten. A rhombus is number 1 is a rhombus. It has 4 congruent sides. 2 should have been a trapezoid. It has exactly 1 pair of parallel sides. And then number 3 should have been a rectangle. Opposite sides are congruent, and it also has 4 right angles. Okay, so when we talked about triangles, we knew that triangles, all of their angles added up to 180 degrees, right? Well, I have something similar that's true with quadrilaterals. So quadrilaterals, the sum of all of the angles of a quadrilateral is 360 degrees. And that makes sense. So if we think about a square, right? Something that we know about a square is that it has 4 right angles, right? So a right angle means that it's 90 degrees. So 90 degrees times 4 angles is going to give me 360 degrees, right? And that's going to be true for any quadrilateral. All quadrilaterals are going to add up to 360 degrees on the inside. So if we go ahead and go back, we're going to apply that. So I might write up here that it needs to equal 360 degrees. So if I look at this first example, I'm given 3 of my angle measurements. I need to figure out what the value of x is. Well, all I'm doing is I'm going to take 115 degrees plus 70 degrees plus 75 degrees plus x needs to equal 360 degrees. So if I add up the 3 numbers that I am given, these 3 numbers are going to add up to 260. So I'm going to have 260 plus x needs to equal 360. That means that x is going to equal 100 degrees. Okay? I want you to go ahead and do the next 2 on your own, and then you can check your answers when you're done. Okay, so for the second one, you should have gotten that x equals 80. The last one, you should have gotten x equals 65 degrees. Okay, and all you're doing there is you are adding up, all the angle measurements, and it should add up to 360. Okay, so this next part, you need to use the dynamic student ebook and Big Ideas to complete the following challenge. So I'm going to show you where to go. So everyone take out your Chromebooks and log into Big Ideas. Big Ideas Math. Okay. So if you log into Big Ideas, this is your homepage should look something like this. And the top part, there's going to be something called the Student Dynamic ebook. Looks like this. So if you click on that, it's going to take you to an interactive, oh, you might have to click on our book. Our book is this red one, Big Ideas Math Red. Okay. So, we are in chapter 7, and we are in section 7.4. And the activity that we're looking at is this activity 3, forming quadrilaterals. So here's what's going to happen, is you're going to move one vertex to create the new quadrilateral. So this first one I need to make from a trapezoid into a kite. So, if I come over here, I'm going to click on this, and it may not, it's not going to be set up exactly like this. So you're going to have to kind of look at what it has here and what, see, 4, 4, 3. So if I move this down here, 1, 2, 3, okay. So this is the starting point, right? So we're going to move this towards the starting point. What your goal is for this is to move one vertex, one point, so that you turn this trapezoid into a kite. Okay, so think about what that would mean. The second one then, so this is going to lead me to the second one. No, it's not. I think the second one's like this. What's the second one like? 1, 2, 3, 1, 2, 3. It's like this. Is that right? Yeah. Okay. So the second one's going to look like this. Again, you need to move one vertex so that you can create, in this case, you're going to create a rhombus. So not a square. You don't want to create a square, you're going to create a rhombus. Okay? So that's going to be your challenge now. So go ahead and try to figure it out and talk to each other, figure out which vertex did you have to move and where did you need to move it to make it that shape, and how did you know that it was that shape? So how did you know that you changed this trapezoid to a kite? What different features did it have? Okay, so spend the next couple minutes figuring out how you would do that. Okay, so go ahead and turn the page. This last part might be kind of tricky for me to show you on screen, but we'll see how this goes. Okay, so we talked about constructing triangles. We can also construct quadrilaterals using similar methods. So here I have a protractor, right? So you're going to need a protractor. Make sure that everyone has a protractor. And we're going to start it very similarly to the way that we've started them before. So I'm going to start by drawing a baseline down at the bottom somewhere. So it doesn't really matter how long it is. Here's my baseline. It's about as straight as it's going to get. Okay, so everyone draw a base. I need to draw a parallelogram with a 60-degree angle and a 120-degree angle. So the first thing I need to do is I need to make my 60-degree angle, okay? So I'm lining up the middle of my protractor with where my line starts, right? And then I know it needs to be 60 degrees, so that happens like right here. I wonder if I can do shapes. Can I do shapes? What is this? Okay, well, it's okay. All right, so here's my two lines. Let me see if I can rotate this as I need to. Rotate. It's pretty close. So here's my 60-degree angle. Almost. Not too bad. Okay, so that's my 60-degree angle. I also know that I need a 120-degree angle. So what I'm going to do is I'm going to take my protractor. I'm going to line it up. Oops. I'm going to line it up with the beginning or the end of this line so that I can create a 120-degree angle. So if I want to, oops, I need to do it like this. Here we go. This is not going to be great. Okay. So I need a 120-degree angle. So that looks like it's going to fall right about here. So now I'll take my protractor, rotate it. Oops, oh no, undo. We're going to line it up as good as we can and connect those two dots. Okay, and here's the other thing that I know. If this is 60 degrees, the opposite side is also going to be 60 degrees. So to round this out, I'm going to take this end and I'm going to make a spot down here at 60 degrees, right down there. And we will connect these guys. Okay, pretty close. So then I'll do my final little line right here. So in this case, I overshot a little bit, right, with my line, but that's okay. Oops. There we go. Okay, so there's my parallelogram. So I'm going to know that these two lines are parallel. This one is parallel to that. This one is parallel to this. And my parallelogram with a 120-degree angle and a 60-degree angle. So that's how I would draw a parallelogram that way. Okay. Next thing, I want you to try this one on your own. I think this one's going to be kind of difficult for me to do up here. Is I want you to try the second one. So draw a right trapezoid whose parallel sides have lengths of 3 centimeters and 5 centimeters. So I'm not going to be able to do exactly what I want, but there's a couple things that we can see in here, right? A right trapezoid. That means that there's going to be a right angle. So the first thing that I would start with is drawing a right angle, right? So let's start with our base. Here's my base. And I need a right angle, so let's line this up. Right angle is a 90-degree angle, so I'm going to put a dash right up here. Rotate this guy. And just like that. So I'm going to start with a right angle. Here's my right angle. So the next thing that I know is that I want the parallel sides to have lengths of 3 centimeters and 5 centimeters. So here's what I would do, is I would make your bases, because if you think about a trapezoid, right, normally the trapezoids we think about look kind of like this, right? And the parallel lines are the top and the bottom, generally. That's going to be the easiest. So have this bottom be one of your parallel lines, which means that your other parallel line is going to have to fall up here somewhere, right? And the two other pieces of information that I have are that, let's see, I'm just going to get rid of this quick. My parallel sides should have lengths of 3 centimeters and 5 centimeters. So I'm going to say that this bottom one is 5 centimeters. Let's make this top one 3 centimeters, right? And so here's whatever, I don't know what 3 centimeters would be. And then your line is going to connect here, right? So this is just a rough sketch of what yours should look like. Yours should be more precise than mine is. So measure it out so that the bottom is 5 centimeters, the top is 3 centimeters, and it has a right angle. Okay, so go ahead and finish this one up on your own. Make sure that all of your parts are correct. And then when you are finished with this, I would like you to do another IXL. And remember, I need you to get to 90. You need to have a SMART score of 90. So go ahead and finish up that as well.